Let's work on week 2, 3.4 homework. So evaluate the given expression and express the result um, in result using the usual form of writing numbers instead of scientific notation. Okay, um, well, I'm going to use calculator here. So let me find it. 1 second. Calculator for permutation. Here it is. All right. First of all, it's as you can see, it's called permutation and combination. They are very similar, but yet not the same. So let's understand, when do we use the permutation, when we use combination, because we will have here both. First of all, we use permutation and combination when we need to make combination out of selected elements from total elements. Okay, so we have basket of some elements. Let's say about here it says 44 elements, but instead of 2, let's take 10, for example. And which 10 you can take it out, and how many combination you can make out of these 10. Now, both of them do the same work, but the difference is, when order is important, we are using permutation. When order is not important, we are using combination. For example, if we do election, order is important, right? We first elect the president, and then president pick vice president, and then cabinet of ministers, and so on. So order is important. Or we take prize. Out of, let's say, 40 participants, there will be only 3 that will win, and its order is important. First place, second place, third place, right? Out of 40. But then can be a case when it's not important, the order. Let's say you have a library of 100 books, and you want to arrange by topic, taking out 40 books based on topic and just dumping some others on some other shelf, and it's not important which book you put first. Okay, that's the case. So when we say P, 44, the 2 out of 44, 44 is the total amount and 2 is selected amount. So let's go here. Total amount is going to be, in this case, 44. And amount for subset, which is R, it's going to be 2. So N is going to be total, R is going to be 2. We click calculate, and we are using the result for permutation. It's going to get 1,892. Good job. Moving to next question. Now here we have combination 2 out of 34. We put 34. And here is 2. Calculate. And there we go. We get 561 combination. Okay. There we go. Question number 3. So decide if the situation involves the permutation, combination, or neither. Explain why. So it says the number of ways 16 people can line up in a row for concert ticket. I would say here we're going to use permutation. Why? Because the line is important, right? You can skip the entire line and go ahead and say that you have priority, you need to get first. So line is important, therefore it's going to be a permutation. Okay, next question. Decide the situation, if the situation involves permutation, combination, okay, the same way, then the same problem. The number of ways a 4-member committee can be chosen from 14 people. Okay, so in this case, what is going to be important? I would say combination, because we just choose 4 people, 4 committee. Which one you choose first, it doesn't matter. Order is not important. Well done. Okay, moving to next person, the next problem about salesperson. So a salesperson must travel to 4 cities to promote a new marketing campaign. How many different ways, trips is possible if route between cities is possible? 4 cities. Okay, if it's gonna be 4 cities and all 4 cities are going to participate, it's gonna be 4 factorial. What does that mean? 4 factorial means you take from 4 all the way to 1, you multiply in the same row, 4 times 3 times 2 times 1. Okay, and that's gonna be, and once we multiply, this is 12, 12 times 2 is 24. Okay, it's 4 factorial. Very good. Next question, number 8. So there are 54 runners in the race. How many ways can runners finish first, second, third? The fact that it's finishing first, second, third, it's already telling us that we are going to use permutation. And it's going to be 3 out of total 54. There we go. Permutation 148,824. 148,824. Excellent. Question number 7. Yeah. So there are 14 finalists in singing competition. The top 4 singers received prizes. How many ways the singer finished first through 4th? Again, it's going to be permutation because we are using prizes first through 4th. So 4 out of 14. So 24,024. There we go. Question number 11. Question number 8. A DJ is preparing a playlist of 18 songs. How many ways can the DJ arrange the first 4 songs on the playlist? What we are going to use here, combination or permutation? So first 4, meaning first, second, third, 4. So it's going to be again permutation, 4 out of 18. 18. And here we have 4. Click on it and we are getting 73,440. Bingo. Next, how many different random samples of size 5 can be obtained from a population whose size is 48? Well, here we are going to use combination because there is no order here required. So 5 out of 48. We calculate a combination 1,712,304. So 1,702,304. Fantastic. Okay, question number 10. a class has 31 students. In how many ways can 4 students from a group form 4 activity? Well, there is no order here required, so 4 out of 31, which means 31,465. There we go. Number 11. So a certain lottery is, when I'm reading lottery, it's already clear that it's a combination, because in lottery there is no order. So 4 out of 26. It's going to be 14,915. And number 12. When testing for current in a cable with 8 color-coded wires, the author used a meter to test 4 wires at a time. How many different tests are required for every possible pairing of 4 wires? Okay. So it is going to be 4 wires out of 8, because 8 color-coded wires. So let's see, 4 out of 8. And it's going to be combination, so 70. And we are done. Okay.